Hello guys, this is Muya from Learn Anything or Everything, and today we're here to talk about triangle ratios in a right angle triangle. The relationships between the angle of a right triangle and its sides are given by 6 ratios. If you were to know these ratios, you can be able to calculate unknown sides and unknown angles of a right triangle. The ratios are as follows. We have our diagram here, which is a triangle with the sides H, A, and O, and the angle theta. These sides are all related to this angle. A is the side adjacent to the angle theta, O is the side opposite the angle theta, and H is the hypotenuse. The hypotenuse is always the side opposite the right angle. The first ratio states that the sine of the angle theta is equals to the opposite side divided by the hypotenuse. The second one states that the cosine of the angle theta is equal to the adjacent side over the hypotenuse. The third one states that tangent of the angle theta is equals to the opposite side over the side adjacent. The fourth one states the cosecant of the angle theta is equals to the hypotenuse, which is h, over the opposite side. The fifth one states that the secant of the angle theta is equal to the hypotenuse over the side adjacent, and the cotangent of the angle theta is equal to the side adjacent over the side opposite. These are the 6 trigonometric ratios of a right angle triangle. But most people might say they're unfamiliar with the last 4: cosecant, secant theta, and cotangent theta. But if we were to look closely, they're related to the above 3. Sine theta is equals to side opposite over hypotenuse. But cosecant theta is equals to hypotenuse over side opposite. These are practically opposites, because as you can see here, side opposite is over hypotenuse. Here it's hypotenuse over side opposite. Let's say secant, so this is the cosecant. If you don't know how to use it, maybe you're familiar with this. We end up using sine to the power minus 1 because they're the opposites. Second, if we were to see cosine, it's side adjacent over hypotenuse. But if we were to see secant, it's hypotenuse over side adjacent. So they've just been swapped. I'm sure you might be more familiar with this. Cosine to the power negative 1. And for cotangent, it's the same as tangent. Tangent, same thing with tangent. The side opposite, tangent theta is equals to side opposite over side adjacent, while cotangent theta is equals to side adjacent over side opposite. So cotangent is practically tan to the power minus 1. If you were to look closely on these normal calculators, you're not going to see these. But we still use these ratios, but instead we're going to use these values. So even in this video, we won't use these, but we'll use these instead, because these 3 are the ones used in elementary mathematics. Then you get to use these others when you go to higher level mathematics. So let's try out a few examples. Before we go to examples, there's this acronym that might be familiar with you if you already know it, but it's handy for you to remember the trigonometric ratios of a right triangle. It says sine theta is equals to side adjacent, sine theta is equals to opposite over hypotenuse. Cosine theta is equals to adjacent over hypotenuse. Tan theta is equals to opposite over adjacent. Just the same way we got them from here. Now we take them there and we get our acronym saying SOHCAHTOA. The sine of theta is equals to the opposite over the hypotenuse. The cosine of theta is equals to the adjacent over the hypotenuse. The tangent of theta is equals to the opposite over the adjacent. And they are easy to remember like that. Let's look at our first example. We've been given this triangle and we've been told to calculate the unknown sides. We can't use Pythagoras theory here because we don't have all three sides. We only have two. We don't have two sides. We only have one. So we're going to use the trigonometric ratios. We have theta. We also have our hypotenuse. So that's good enough. Let's start with A. A, which side is A? If we were to look at A is the side opposite theta. So if we want to use the side opposite theta plus the hypotenuse, because this is H, it's just that it was indicated as A. But if you were to look at in reference to the, oh, not H, sorry. This is O, which is the side opposite the angle theta. So if we want to use the side opposite the angle theta plus the hypotenuse, there's only one ratio which has that, and that's the sine of theta. So we place it in there. We say the sine of theta is equals to the opposite over the hypotenuse. The sine of my theta is 30 degrees is equals to opposite side is A, my adjacent side, I mean that my hypotenuse is 5. If I were to cross multiply these, I get A equals 5 sine theta. I get A equals 5 sine theta, yes. So let's place that in our calculator and we find how long A is. We said it's equal to 5 sine theta, which gives us 2.5. It means our A equals 2.5. And we've solved one side using the trigonometric ratios, that A is 2.5. For the third side, we can even use the Pythagoras theory, but I want us to get used to the trigonometric ratios, so let's use them as well. We have theta as our angle. We have our side opposite theta, and we have the hypotenuse. So let me use these two. Let me use the side opposite and the one I don't know, which is the one adjacent. If I want to use the one opposite and adjacent, I'll need the ratio which involves both of them, which is tan theta is equals to opposite over adjacent. So I get it. I say tan theta equals opposite, which is O over adjacent. Tan, my theta is 230 degrees, is equals to, my opposite is 2.5. My adjacent is B. I do not know what B is. Cross multiply, you get B tan 30 degrees, sorry, is equals to 2.5. Divide by tan theta, tan 30 degrees, which is tan 30 degrees, divide by tan 30 degrees. So we get B equals 2.5 over tan 30 degrees. B, we said B is equals to 2.5 divided by the tan of 30 degrees. Of 30 degrees gives us 4.3. This means our B equals 4.3. Thank you guys for watching. Just trying to help you out on the 6 trigonometric ratios. Be sure to look out for the next videos. Thank you.